Hello dear students, let me introduce myself again. I am Vinit, I am your senior chemistry faculty. So let us start the unit 2, acids and bases. Acids, bases and salts. Okay. Chemical properties of acids and bases and common characteristics of acids and bases. So what are the common characteristics? It may be electrical conductivity, dilutions and reactivity of the acids and bases. Next, pH in our daily life. So what is pH? So to know the strength of the acids and bases, we have a scale called pH scale. So that pH is nothing but potential of hydrogen. So with the help of hydrogen concentration, we will know the strength of the acids and the strength of the bases. Okay, next. More about salts. So we know that salt is doesn't mean salt meaning it's a crystalline and white in color and which is neutral. When we mix acids and bases gives salt. So we know only salt is nothing but sodium chloride, but there are many salts and they are acidic and basic also. We can prepare more compounds with the help of salt. Okay, and activities. So all the chemical properties and the common characteristics of the acids and bases, we will understand these topics with the activities. Okay. Next, last is NCERT questions. So let me start the first topic of our unit 2 is chemical properties. Okay. So first, chemical properties of the acids and bases, we will understand with the activity 2.1, that is we have taken some chemicals like there may be acids, bases and salts. Okay, so we will understand which chemicals are acids and which are bases with the experiment, that is activity 2.1. In that we have red litmus, blue litmus, phenolphthalein indicator and methyl orange indicators. So what are these indicators? We already know that red litmus is used for the bases. So when you dip the red litmus in the base, it will change its color into blue. And also when blue litmus dipped in the acidic solution, it changes its color into red. So we only know about this blue litmus and red litmus. Okay, so this is blue litmus and red litmus. Blue litmus is used for the acids and red litmus is used for the sake of bases. Okay, next, these are the two artificial indicators which are used to identify the acids and bases. Okay, these two are called as, like this phenolphthalein indicator is called as pH indicator, or else it can be also called as acid base indicator. Okay, so it indicates only base but it won't change its color in the acidic solution. So let us assume take a base and drop a few drops of phenolphthalein indicator in that base, it changes its color into pink in color. But phenolphthalein indicator in the acidic solution, it won't change its color. So that means phenolphthalein indicator indicates base, whereas it doesn't indicates the acid. It will be same, it gives same color in the acidic solution, whereas in the base it gives pink in color. Okay, so in methyl orange also. So methyl orange is called universal indicator and it's also a pH indicator. Okay, so pH indicator. So when methyl orange reacts with the acid, it changes its color into yellow in color, whereas for the bases, it changes its color into red in color. Okay, so two colors, yellow and red. Okay, yellow color for the acids, red color for the bases. Okay, so we will understand the acids and bases with the test, litmus test, red litmus and blue litmus test, phenolphthalein indicator and methyl orange. Okay, so these are some chemicals. We don't know which one is acid, which one is base. So to understand the acids and bases, we are going to conduct an experiment with the help of litmus papers and the indicators. Okay, next. So how can we identify this? So when you dip these solutions like HCl, H2SO4 and HNO3 CH3COOH, that is acetic acid. These all solutions are acids, so they change its color in the blue litmus only. So you can find the changes in the blue litmus, whereas red litmus doesn't change its color because these solutions are acids. Okay. Next, these solutions like NaOH, calcium hydroxide, KOH, potassium hydroxide, MgOH taken twice, magnesium hydroxide, NH4OH, ammonium hydroxide. So these are some bases, okay, which change their color in the red litmus. So they change the color of the red litmus to blue, whereas blue litmus doesn't change any color, okay. And phenolphthalein indicator and methyl orange indicators. So what are the observations you can find in the phenolphthalein indicator and the methyl orange indicator? So when phenolphthalein indicator reacts with the acids, they won't change its color. It won't change its color, so it will be colorless, no change, okay, no change for the acids. So these are this four: HCl, H2SO4, HNO3 and CH3COOH is comes under acidics, okay, whereas this comes under base, okay. So these four solutions are acids which doesn't change its color in the red litmus, show change in color in the blue litmus, whereas no change in the phenolphthalein indicator, whereas in the methyl orange there will be a change. Which color? Yellow color, okay, yellow color. Here four solution gives yellow color. Why? In the sense yellow color, okay. Whereas NaOH, okay, NaOH, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide will change its color in the phenolphthalein indicator pink in color, pink. So they indicate pink in color, whereas methyl orange will change its color into red, okay, red, okay, red color. So methyl orange indicates the acid solution into yellow and basic solutions into red color. So that means these are the acids, these four are acids and the remaining are bases. So you can find some differences in the acids and bases. Here there are hydrogen is common in the acids, whereas OH, NaOH, OH is common in the bases. But here you can find OH also here. But why it is acid? So we will understand the acids and bases with some more activities in the next slides, okay. So that is onions as the olfactory indicators, activity 2.2. So what are olfactory indicators? So note down the definition. Olfactory indicators are the indicators which on reacting with the acid or bases will change their smell. Smell in the sense odor. So let me repeat once again. Olfactory indicators are the indicators which on reacting with the acids or bases will change their smell. So here onion, so there is one experiment in the activity 2.2, that is, so take a piece of onions, take pieces of onions like chopped onions and place them in the bag with a cloth, okay, with a cloth in it, okay. Take a bag and in that put some chopped onions with a cloth, okay, cloth. Keep it in the freezer for 12 to 24 hours, okay, 12 to 24 hours, unless and until the smell of the cloth should be onion, okay. When you smell the cloth, it should be onion smell. So take this cloth after 12 hours or 24 hours. So when you smell the cloth, it smells like onion. So make it into two pieces and react with acid and bases. React with, so two pieces, make it into two halves. Cloth, make the cloth into two halves. That is reacted with HCl and NaOH. So when you pour HCl and NaOH on the cloth, onion cloth, what happens? Strong pungent smell. means same onion smell will be same in the cloth which is reacting with the HCl, whereas the cloth which is reacting with the NaOH will change its smell. Weak or no smell. Weak or no smell means, that means the onion smell is reacting with the base, that's why there is a change in smell. So the indicators which are reacting with the acids or bases will change its smell are called as olfactory indicators. Okay, so onion comes under the olfactory indicator because when it react with the base, it changes its smell. So not only base, acid also. So here, so there are some indicators given here: onion, jasmine and vanilla essence, vanilla essence, clove and lemon. So these are called as olfactory indicators. Olfactory indicators are the indicators which on reacting with the acids or bases will change its smell. So here onion will doesn't change its smell in the acidic, whereas vanilla essence, sweet pleasant aroma and strong spicy fragrance in the clove and strong citrus smell. So whereas here, so there is no change in the smell. So here the smell is getting changed. That means these indicators are reacting with the base, so they change their smell. So these are called as olfactory indicators. Olfactory indicators means, let me repeat once again, that is olfactory indicators are the indicators which on reacting with the acids or bases will change their smell. Okay, hope you understand about the olfactory indicators. So if there are any questions about this topic, so you can ask in the comment section. Okay. Metal versus acid. So these are the chemical properties of the acids and bases. So first chemical property is when metal reacts with the acid. So what happens when metal reacts with the acid? So let me give an example for metal. So there are many metals, like let me take an example, zinc. So here also we have an experiment, that is activity 2.3. So zinc granules reacting with the dilute sulfuric acid. So it produces some gas that is transferred into the soap solution. Why we are using soap solution? Because it traps the gas. So here zinc, when it reacts with the H2SO4, sulfuric acid is nothing but H2SO4, which gives zinc, when it reacts with the H2SO4, gives zinc reacts with sulfuric acid and gives ZnSO4, zinc sulfate plus hydrogen gas. That gas is transferred into the soap solution so that to trap the H2 gas. So H2 gas can be identified with the test called ignition test. So when you take a matchstick, lighting matchstick near the hydrogen gas, it makes a pop sound and it puts off the matchstick. That means hydrogen gas is highly inflammable. So let me give another example. Let me pick one question from the comment section. Yes, sir, do experiment with the magnesium. Okay, yes. So magnesium is also a metal. When it reacts with the any acid, like there are many acids, let me take an example, HCl. Okay, HCl. So when magnesium reacts with the HCl, it gives magnesium reacting with the HCl gives MgCl2 magnesium chloride plus H2 hydrogen gas. Okay, H2 hydrogen gas. Why MgCl2? Why only MgCl2 is coming when magnesium is reacting with the HCl? So because magnesium is a metal which is a cation and hydrogen is also a metal. According to the periodic table, it's also a cation. So cation displaces the cation. So when cation displaces the cation and anion makes a bond, that is nothing but it gives salt. So general representation of the metal and acid reaction is, so metal when it reacts with the acid, or base, not only acid, base, it gives salt plus hydrogen gas. So this is the general representation of the metal and acid reactions. Okay. So this experiment tries to make you understand that the products from the metal and acid reaction. Okay. So hope you understand this experiment. So if you have any doubts in this topic, you can ask, you can use the comment section. Okay. Next. Metal versus base. Same reaction, metal with acid. We are just now we discussed the metal with the acid. So now metal with the base. So metal is zinc. Same zinc is reacting with the NaOH. It gives Na2ZnO2, sodium zincate plus hydrogen gas. So this will be salt plus this is hydrogen gas. So when metal reacts with acid or base, the common product will be hydrogen gas and there will be a salt formation. Okay. So metal acid or metal base gives hydrogen gas plus salt. Next. Activity 2.5. What is it? Metal reacting with metal carbonate reacting with the acid, metal hydrogen carbonate reacting with the acid or base. So here metal carbonate or metal hydrogen carbonate. What is carbonate? So let me know in the comment section. Carbonate, CO2, no, it is not CO2. CO2 is carbon dioxide. Yes, CO3. Carbonate is CO3 minus 2. Charge of the carbonate is minus 2. So when carbonate reacts with any of the metal, when carbonates, not only carbonate reacts with the metal, so carbonate when it makes bond with the metal, the formula will be, for example, metal like sodium, when it reacts with the carbonate, it gives Na2CO3. Na2CO3, sodium carbonate, Na2CO3. Na2CO3 is a metal carbonate when it reacts with the acid. So what is this experiment? This activity 2.5 is an experiment with the sodium bicarbonate and HCl, hydrochloric acid, which gives a gas called CO2. Okay. So how can we do that experiment? Okay. So general representation of the metal carbonate, metal CO3, CO3 means metal carbonate when it reacts with the acid or base. So acid or base, what are the products? Okay. When it reacts with the metal carbonate reacts with the acid or bases, it gives salt, common salt, plus carbon dioxide plus water. So this is the general representation of the reaction between metal carbonate acid or metal hydrogen carbonate acid. So let me give an example. So Na2CO3, when it reacts with the HCl, let us take an example with HCl only, same. Na2CO3 reacting with HCl, it gives, Na displaces the hydrogen, it gives NaCl, sodium chloride, plus carbon dioxide CO2, and the remaining hydrogens will react with the oxygen, it gives H2O. It gives H2O. So this will be the general representation of the metal carbonate reacting with the acid, gives salt, carbon dioxide and water. Okay. Next, metal hydrogen carbonate. So metal hydrogen carbonate, same, sodium hydrogen carbonate is called metal hydrogen carbonate or metal bicarbonate, sodium bicarbonate. It gives, when it reacts with the HCl, it gives same products, NaCl, but in different proportion, plus carbon dioxide plus H2O. Okay. So why we are using a delivery tube to transfer the gas into the other test tube? because we want to find which gas is being released from this experiment. So this is releasing a carbon dioxide, CO2 gas, that can be identified with the lime water. So how can we identify with the lime water? So here, when carbon dioxide reacts with lime water is CaO or calcium hydroxide. Let us assume calcium oxide or calcium hydroxide. Calcium hydroxide, it gives CaCO3, calcium carbonate plus H2O. So this calcium carbonate will be the precipitate in the experiment. So when carbon dioxide reacts with the lime water, it gives a white precipitate. That white precipitate is nothing but the calcium carbonate, and the remaining thing will be water. So how can we identify the calcium carbonate? How can we identify the carbon dioxide? Sorry. So carbon dioxide can be identified with the lime water. So when you transfer the carbon dioxide into lime water, it gives a white precipitate. That white precipitate is nothing but the calcium carbonate. So this is what the experiment of metal carbonate with the acid, metal hydrogen carbonate with the acid. So hope you understand the reaction between metal carbonate, metal hydrogen carbonate versus acid. Okay. So next, chemical properties of acids and bases, activity 2.6. So what is that activity 2.6? So to understand the reaction between the acid and bases. So how can we identify and what is the general representation of the acid reacting with the base? So here, so when acid reacts with base, it gives salt plus H2O water. So how can we identify the formation of salt and H2? And what will be the neutral point? So acid and base, when they react together, it becomes neutral. So how can we identify there will be a neutral point? So with an experiment called activity 2.6, so we can identify the neutral point. So take a test tube with NaOH. NaOH is what? What is NaOH? Let me know in the comments. NaOH is sodium hydroxide. Yes, NaOH is sodium hydroxide. NaOH can be identified with which indicator? So in previous activity we have done with the phenolphthalein indicator test and red litmus, blue litmus, methyl orange test. So which indicator is best for the base? Red litmus, it is not it is an indicator, but it is a physical indicator, dry indicator. We want a liquid indicator. Yes, phenolphthalein indicator is the base indicator. So when you add phenolphthalein indicator to the NaOH, it gives pink color. Okay, pink color solution. It gives this pink color solution. So pink color solution, when you add acid to this pink color solution is nothing but NaOH with the phenolphthalein indicator. Phenolphthalein indicator. So NaOH with the phenolphthalein indicator gives pink in color. So when you add HCl to the solution, gradually the pink color disappears. That means, so the neutralization point, neutral point is approached. So at the point where the solution is colorless, the point where the solution is colorless, then the acid and base reacting gives salt and H2. So that salt, when it reacts with the phenolphthalein indicator, it will be colorless. So phenolphthalein indicator can identify only base, but it won't react with acid or salt. It will be colorless in the acidic and salt solution. So when acid and base react together, if there is a neutral point, the pH, the phenolphthalein indicator indicates the colorless solution. Whereas if the base quantity is more in the solution, in this solution, the pink color will be same. So when you add the acid this to this pink color, HCl, it gives colorless solution. So this is how you can identify the neutral point with the phenolphthalein indicator. But also with the methyl orange also we can identify the same solution. So in the place of phenolphthalein indicator we can use methyl orange. So when you add methyl orange to the acid or base, if you take acid, when you add methyl orange to the acid, it gives yellow color. When you add again base to it, it will be colorless. Why it will be colorless? I mean, it gives the same methyl orange color because when acid and base react together, it gives a neutral point. Neutral point cannot be identified with the methyl orange. Okay? So hope you understand the reaction between acids and bases. So let me give an example with the acid and base reaction. So acid base reaction. Give me one example of acid and base that on reacting with the gives salt and water. Yes, HCl, most common acid is HCl. HCl which on reacting with base NaOH gives salt, common salt NaCl plus H2O. So this is what happens when acid react with the base, gives salt and water. Okay, hope you understand the acid and base chemical reaction. So next is activity 2.7, metal oxide reacting with acid. So what will be the metal oxide? So what is oxide actually? Oxide is, yes, oxygen. Okay, oxide is oxygen. When oxygen makes bond with the metal, it gives, so one example for the metal, zinc or magnesium or calcium. So let me take an example of zinc. React with the oxygen is zinc oxide. So zinc oxide, when it reacts with any acid like H2O, HCl or H2SO4, so any type of acid, it gives, metal displaces the hydrogen, it gives zinc plus chlorine, ZnCl2, zinc chloride plus hydrogen always tries to make bond with the oxygen, it gives H2O. So that means metal oxide when it reacts with the acid gives salt and water. What is the difference between the metal oxide and the metal? Metal when it reacts with the acid, metal like zinc when it reacts with the acid, it gives zinc chloride ZnCl2 plus hydrogen gas. ZnCl2 plus hydrogen gas. Why here water? Because there is a oxygen in the reactants. So hydrogen always tends to make bond with the oxygen, it gives water. Okay, sorry. So zinc when it reacts with the chlorine, it gives salt. So the general representation of the metal oxide reacting with the acid will be metal oxide reacting with acid gives salt plus water, H2O. Okay, so this is what happens when metal oxide reacts with the acid. So in activity 2.7 you can find a metal oxide reacting with the acid. So there may be a zinc oxide or metal oxide like magnesium oxide, calcium oxide, any example. Okay, so and how can we identify this hydrogen gas? So let me know in the comment section. Yes, ignition test. So with the help of ignition test we can identify the gas. Okay, so next, non-metal oxide with the base. So here there are many non-metals in the periodic table. So one of the example is carbon. Why we are taking carbon only? We can take other also, sulfur, nitrogen, any other. But carbon when it makes bond with the oxygen, it gives carbon monoxide or carbon dioxide. So non-metal oxide. So here carbon dioxide, CO2. CO2 when it reacts with the base. So any one example for the base except NaOH. Yes, there are many bases. So calcium hydroxide. So calcium hydroxide CaOH taken twice. Why only this example? We have already used this example in the previous slides, that is to identify the carbon dioxide with the lime water. So this will be the lime water, which is a base. So lime water, when it reacts with the carbon dioxide, the products will be, let me know in the comment section. Calcium carbonate. Yes, calcium carbonate, CaCO3. So how can we identify the calcium carbonate? Yes, it is white precipitate. It is white precipitate with a water. Okay, with water. So when non-metal oxide reacts with the base, the products will be same. This is also a salt. It is an insoluble precipitate. It goes bottom to bottom of the test tube and it gives water. Okay. So when non-metal oxide reacts with the base, it gives precipitate. One example is precipitate with the water. Okay. So hope you understand the non-metal oxide versus base. So next is in-text questions. So in the middle of the topics, you can find some questions. So some of them are this. Okay. So why should curd and sour substances not kept in the brass or copper vessels? So this brass and copper are metals. So metal, when they react with the sour substances, curd or sour substance. What are curd and sour substances? What is the nature of the curd and sour substances? Let me know in the comment section. Yes, they are acidic in nature. Okay. So when acid reacts with the metals, it gives hydrogen gas plus salt. So hydrogen gas is very harmful, and the salt formed when the metal reacting with the acid is very toxic. So that is why we should not store sour taste or acid solutions in the metal containers. That is why we have to use the containers which does not react with the metals. Okay. So next, which gas is usually liberated when the acid reacts with a metal? So we already know that when metal reacts with the acid, it gives hydrogen gas. It gives hydrogen gas. So hydrogen gas is highly inflammable. When metal reacts with acid, it releases hydrogen gas. Next, illustrate with an example. How will you test for the presence of this gas? Yes, so metal like zinc, when it reacts with the HCl, gives zinc chloride, ZnCl2 plus hydrogen gas. So this hydrogen gas can be identified with the flame test. So hydrogen gas is highly inflammable. When hydrogen gas reacts with the air, it gives a pop-up sound and it puts off the fire. Okay. So it is very highly inflammable. Next, metal compound A reacts with dilute hydrochloric acid to produce the effervescence. Okay. What is it? Metal compound reacts with dilute hydrochloric acid to produce effervescence. What is effervescence? So what is the meaning of effervescence? So effervescence is nothing but CO2, carbon dioxide. So in the experiment, the carbon dioxide can be identified with the lime water, and also it gives a white bubbles and gas. White bubbles with the gas is called effervescence. So when the effervescence is being released, so when metal with the carbonate means metal carbonate like Na2CO3 sodium carbonate or NaHCO3 sodium bicarbonate gives a Na2CO3 or NaHCO3 gives a carbon dioxide when they are reacting with the acids. Okay. So metal compound. So metal compound may be a sodium carbonate or sodium bicarbonate. Metal carbonate, any metal carbonate. So reacting with the dilute hydrochloric acid, it produces a effervescence. This effervescence is CO2. The gas evolved extinguishes a burning candle. So yes, so CO2 is used to extinguish the fires. So there are some red color cylinders in the petrol pumps. Not only in the petrol pumps, many institutions also that contains a CO2. that extinguishes the fire. Okay. Next, write a balanced chemical equation for the reaction if one of the compound formed is calcium chloride. So one of the compound is calcium chloride. So that means the metal carbonate should contain the calcium. So here the reaction will be, so this may or this may not be metal compound, but here they have given a hint called metal chloride, that is calcium chloride. So calcium carbonate, CaCO3, calcium carbonate, when it reacts in the presence of HCl, dilute hydrochloric acid, it gives a salt that is nothing but calcium plus chloride, calcium chloride, CaCl2 plus, and the remaining will be CO2, carbon dioxide plus water, H2. Is it a balanced equation? Let me know in the comment section. Here, calcium, 1 calcium, 1 calcium, 1 chlorine, 2 chlorines, oxygen, 3 oxygens, here 3 oxygens balanced, carbon, carbon balance. Now we want to balance only chlorines and hydrogens. So just keep 2 here, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Now it is balanced chemical equation of metal compound, that is metal carbonate reacting with the hydrochloric acid gives salt calcium, calcium chloride with carbon dioxide and water. Okay, next. Common properties of acids and bases. So there are some common properties of acids and bases which can be, first is electrical conductivity. So what is electrical conductivity? How this acids and bases can conduct electricity. So when acid like HCl dissolved in the water, in a water is nothing but aqueous solution. So when HCl reacts with acid, it gives, so HCl will be divided into H plus and Cl minus in the acid in the water. Okay, so this H plus reacts with H2O, it gives H3O plus Cl minus. Okay, so there are plus ions and minus ions which can conduct the electricity. So what is the meaning of electricity? The flow of charges, flow of positive charges or negative charges is called electricity. So there are positive charges and negative charges that can be flowed in the reaction vessel, that is this container. This complete reaction is called electrolysis. So in this, so we have taken the HCl solution when they reacts with both these electrodes. So here this is a positive, this is a bigger one is a positive, shorter one is a negative. This is negative, which is called as cathode, and this is the anode. So anode and cathode. So here this positive ions are move towards the negative electrode and the negative ions moves towards the positive electrodes. This makes the electricity to transfer from one place to another place. That is why the acidic solutions can conduct the electricity with the help of hydronium ion. This is called hydronium ion. Okay, hydronium ion can conduct the electricity in the acidic solutions, whereas in the basic solution, like NaOH, when it is dissolved in the water, it gives Na plus and OH minus. This OH minus and Na plus are responsible for the conduction of electricity in the aqueous solution. So the common properties of acidic and basic solutions are they can conduct the electricity. So acids or bases in aqueous state can conduct the electricity because in aqueous state they produce ions, positive and negative ion. That is why they can conduct the electricity. Okay, hope you understand the common properties of acids and bases, which is nothing but electrical conductivity of acids and bases with activity 2.8. So just go through the activity in your textbook, NCERT textbook. So that is nothing but the electric conductivity of acids and bases. Okay, next, acid versus salt. So what happens when acid reacts with the salt? So let me take an example that is already given, H2SO4. This is activity 2.9. So H2S4, when it reacts with the NaCl, H2SO4, when it reacts with the NaCl, so what will be the products? Just guess the products in the comment section. Let H2SO4 plus NaCl. So H2SO4 plus NaCl. So here what happens? H2 hydrogen will replaces this sodium. It gives, and sodium will react with the SO4. So what are the products? Yes, very good. HCl plus Na2SO4. HCl plus Na2SO4. So H hydrogen will react with the chlorine, gives HCl. That is nothing but gas. That is nothing but gas. So here in this case, in this experiment, the HCl will be gas that can be identified with the litmus. Which type of litmus paper? Which type of litmus paper? Sorry, blue litmus. It can be identified with blue litmus. So blue litmus, but we should use wet blue litmus. Why only wet blue litmus? Because, so first, blue litmus is used to identify the acid, and wet blue litmus because it can capture the moisture in the air. So HCl gas can be identified with the wet blue litmus, not the dried one. Okay, so hope you understand this acid and salt reaction. It gives HCl gas plus Na2SO4, sodium sulfate. Sodium sulfate is a salt and HCl is a gas formed in this. Okay, hope you understand this acid and salt experiment with this activity 2.9. So in this activity, just go through the textbook. In this activity, the HCl gas is released. That HCl gas can be identified with the blue litmus paper, wet blue litmus paper. Okay, yes. So next common property is dilution of acid and base. So what happens when acid or base is diluted? So acid or base, when they react with the water, they get diluted. So diluted is nothing but when we add water to the solution, that becomes a dilute solution. So what are the precautions you should follow while making a dilute solution of hydrochloric acid and the base? Base, which is NaOH also, any type of base. So here acid plus water, H2O, is a highly exothermic reaction. It's a highly exothermic reaction. So highly exothermic reaction, when highly exothermic reaction occurs suddenly, it releases the more temperature. It releases more temperature, which can cause a damage to your body parts. I mean, it splashes out the solution. So acid, when it reacts with the water, it releases the high intensity of heat that makes the solutions to splash out. So that is why you should not add acid to the water rather than adding. When you are adding water directly to the acid, it releases the heat which is highly exothermic. So the solution will splash out. So water is not added to the acid. Whereas you can take let us assume 1 liter of water, 1 liter of H2O. In that is in the container. In that you can add the dropwise HCl, acid, or any type of base. So which makes the solution less exothermic, and it is easy to dilute the HCl with this procedure. So always remember, water is not added to the water. Rather than adding water to the acid, we will add acid to the water in a dropwise manner, not in a complete manner. Okay, so acid is added dropwise to the water. Okay, yes. So this is what the dilution of acid and bases. What are the precautions you should follow? Water should not be added to the water, whereas you can add acid to the water in a dropwise manner. But in the case of base, you don't need to follow the precautions. You can directly add water to the base or else base to the water, because it is not highly exothermic in case. Okay. Yes. Next is in-text exercises. So what are these in-text exercises? So why do HCl or HNO3 acid, HCl and HNO3 acid, etc. like show acidic properties in the aqueous solution, while solutions of compounds like alcohol and glucose does not show the acidic properties? Because HCl and HNO3, when they mixed in the water, they give H plus. This will give H plus and Cl minus. HNO3 gives H plus and NO3 minus. So they form positive and negative ions in the presence of water, whereas glucose solution or alcohol solution does not give this plus or minus charges. That is why acidic solution can show their acidic properties in the aqueous solution. Next, why does an aqueous solution of acid conduct electricity? So aqueous solution of acid will conduct the electricity because in the aqueous state only they will give positive or negative ions. Okay, they will give positive or negative ions. So that is why the aqueous solution of acid can conduct the electricity, but not the solid or gaseous state. Why does dry HCl gas not change the color of the dry litmus paper? Because dry HCl gas can be caught with the help of wet litmus paper, because the air does not reacts with the dry items, whereas you can use the wet items to capture the air. So in an experiment, when H2SO4 reacts with the salt, it gives HCl gas, which is HCl, which is acidic in nature, that can be identified with blue litmus paper, which should be wet. Okay, always remember, wet litmus paper should be used to identify the acidic solution which is in gaseous form. Okay. Yes. While diluting an acid, why it is recommended that the acid should be added to the water and not water to the acid? We already discussed in the dilution, that is highly exothermic, so water should not be added to the acid, whereas you can add acid drop wise manner to the water. Okay. Next, how is the concentration of hydronium ion affected when the solution of acid is diluted? So acid is diluted. So when acid is diluted, the hydronium ion concentration increases. That makes the solution to conduct the electricity, and also they will show the acidic properties. Next, how is the concentration of hydroxide ion affects when excess base is dissolved in the solution of sodium hydroxide. Sodium hydroxide, when it dissolves in the water, it produces the Na plus and OH minus. So this OH minus, when OH minus concentration increases, the conductivity of electricity increases. But at some point, OH ions will be completely filled in the solution, so it won't conduct the electricity. At high dilution, it won't conduct the electricity. It decreases the conductivity of electricity. So remember, NaOH on dissolving in the water can conduct the electricity, and HCl or else any type of acid dissolving in the water can conduct the electricity. Okay, hope you understand about this common properties of the acids and bases which can conduct the electricity. Next, so to be continued. So what are the topics? So till now we have discussed the chemical properties of acids and bases with the activities and NCERT questions. So in the middle of the textbook there are some questions, that questions we have just now we discussed. Okay, so here pH and its everyday effect in our everyday life, and more about salts is left. Okay, is the pH. Okay, so what is pH? What is the meaning of this pH? Okay, so pH, the abbreviation for the pH is the full form for the pH is potential of hydrogen. Okay, potential of hydrogen. So what is hydrogen? So in the acids and bases, you can find a common thing is a hydronium ion. That hydrogen is responsible for the strength of the acids or bases. So this is a pH scale. So this is not an actual pH scale. So in pH scale, there are some values from 0 to 14 values. So 0 to 14 values. So here 0 to 14 values. So this red color part indicates the hydrogen ion concentration, and this blue color part indicates the OH minus concentration. So when the concentration of H plus decreases, that will move towards the basicity. When the OH minus concentration decreases in the solution, that gives a acidic nature. Okay, so here in a solution, let us assume in a solution HCl. So in this HCl, when this HCl dissolved in the water, it gives H plus and Cl minus. Here the H plus concentration is more. So that gives a value of 0 to 4, between the 0 to 4. Whereas in the CH3COH, which is an acetic acid, here the hydrogen and OH concentration is almost, so we have OH also in this acid. That is why this will gives a value of 4 to 7. Okay, 4 to 7, which will be the weak acid, and it may be a base. Okay, it is near to the base, but it is far away from the acid. So here from the 0 to 7, from 0 to 7 will be acidic, and before 7 means 0 to 6 will be acidic, and 8 to 14 will be basic. Okay, and here, so strong acid is a weak base, weak acid will be a strong base. Okay, so with the help of hydrogen concentration, we will understand the strength of the acids and bases. So in strength, in the acids, the strength of the hydrogen ion will be more, whereas in the base, the strength of the OH ion will be more. So as the OH ion concentration decreases, H plus ion concentration decreases. So OH minus concentration is decreasing, hydrogen ion concentration increases. That means OH ion decreases, that means acidic nature increases. H plus ion concentration decreases, OH ion concentration increases, that means it will be basic in nature. So this is not included in your textbook, but there is a certain image which compares the H plus and OH minus concentration. So H plus ion concentration will describe the acidity, and whereas OH minus will describe the basicity. Okay, okay, please try to understand. Let me repeat once again. So H plus will indicate the acidity, OH minus indicates the basicity. Okay, there are some theories with the help of OH minus and H plus. They are Arrhenius theory, Lewis acid base theories. So this and Bronsted acid base theory, that will be studied in the grade 11. Okay, so this is not included in your textbook. This image will be there in your textbook to compare the hydrogen ion concentration and OH minus concentration. Okay, so here, so we will try to understand the pH of the different solutions. That is, first one is saliva before the meal, saliva after the meal. Okay, lemon juice, aerated drink. Aerated means carbonated drink. So when the carbon dioxide is transferred to the drink, it gives a soda. Okay, it is nothing but the soda. So aerated drink, carrot juice, tomato juice, coffee, tap water, 1m NaOH. NaOH is base, we already know that. 1m HCl. So what is the meaning of 1m? 1m molarity. It's a concentration, fixed concentration. So we know that before a meal, just we are assuming that before a meal the saliva will be acidic, because before a meal the stomach releases the HCl acid that gives a pH value of acidic nature. So let us assume the value will be around 0 to 5. Okay, 0 to 4, let us assume 0 to 5 or 4, and the approximate value, color of the pH will be red in color, red or orange, and approximate pH value will be 0 to 4, and the nature of the substance will be acidic. Okay, but after the meal the stomach will react with the bile juice. The stomach acid will be, the concentration decreases, it becomes the saliva becomes basic in nature or neutral. Okay, so it gives a neutral or basic. And aerated drink, so lemon juice is acidic, it gives a red, and pH value from 0 to 5, and nature of the substance will be acidic in nature. So this all we will do in experiment with the pH indicator. There are two types of pH indicator, liquid form and the dry form which is a paper form. Okay, so a dry form, when you dip the pH paper in the solution, it gives us color. With the color you will identify the whether it is a acidic or basic. Okay, so what are the values of this? Okay, so first, saliva before meal is green. So why it is green? It is neutral. So before a meal means, see, if there is a hunger pants means when acid released in the stomach, it gives a acidic. It is acidic. When acid fumes reacts with the saliva, it gives a acid nature. But before a meal means without hunger sensation, it gives a green and it is neutral. Whereas after a meal, yellow green, because slightly the acid is acid is being released in the stomach to digest the food. So that is why it is yellow green, slightly acidic. And lemon juice gives red in color because lemon is a citrus fruit, acid, and the value is 2 acidic in nature. And aerated drink, orange, slightly acidic. Okay, it's a slightly acidic. So carbon dioxide, when it reacts with the water, it gives a carbonic acid, HCO3, which is a carbonic acid, which is acidic in nature. Carrot gives a yellow, almost it is equal to the neutral, 6, slightly acidic. Okay, slightly acidic. Tomato juice taste will be sour in taste. So that is why it gives a orange or red color, and with the 4 value, pH value 4, and the nature of the substance will be acidic. Okay, next, coffee also yellow and orange. So when you drink the coffee with the people who are having the coffee with the acidity problem, it increases the acidity nature. Okay, so coffee also is a acidic substance. The value of the coffee is 5 in the pH scale. Next, tap water will be neutral, 7. And NaOH is a strong base which gives a dark blue. The value will be 14 and basic. Whereas HCl is a strong acid which gives a value of 0 and strongly acidic in nature. Okay, so hope you understand the pH value and pH colors of the acids and bases and neutral solution. Okay, for acids the values will be 0 to 6, and neutral 7, and 8 to 14 will be bases. Okay, hope you understand the pH scale and the values and colors of the pH scale with this experiment activity 2.11. Okay, activity 2.11. So next is pH scale. So this is how the pH scale would be. So this is the colors of the pH. So red, so slightly red color is changing into yellowish green. So this is a neutral, and after this goes on, gives a blue color. So dark blue, light blue to the dark blue. So this indicates the base, whereas this is an acidic solution and neutral. Okay, so this is the pH. There are some examples for the pH values also. Just now we have done the experiment, the activity 2.11. Okay, next, importance of pH in everyday life. Okay, importance in pH in everyday life. So in day-to-day life there are many advantages of acids and bases. Acids or bases are nothing but which gives a pH. There is a certain pH range. If there is a fixed pH range, the reaction occurs naturally. It would be common. But when the pH value is different, there will be a disadvantage. Like here, our body works within the pH range of 7 to 7.8. Okay, that means neutral. Okay, but when the rainwater, see, we know that the water comes from the rain, so which is filtered and used for the drinking, for the sake of drinking. So rainwater pH is around less than the 5.6, which less than the 5.6 means which is acidic in nature. So that means it causes acid rains. So when greenhouse gases like carbon dioxide, sulfur dioxide, nitrogen gas increases in the atmosphere, that decreases the pH value of the water, and which cause the acid rains. Okay, so acid rains can lead to the death of aquatic animals, not only aquatic animals, which also affects the health of the human beings and animals on the earth. Okay, so always the rainwater pH should be more than 5.6 but not less than the 5.6. So the fixed range should be 7 to 7.8. Okay, so this is the first and most important thing of the pH scale. Okay, pH, uses of the pH in the everyday life. That is, the pH is of the rainwater should be more than 5.6, not less than the 5.6. Okay, it is considered as acid rains. Next is importance of pH. What is the pH of the soil in our backyard? And test with the pH indicator. Soil test with the pH indicators. So take some soil in your garden, okay, in your garden or in a plant, potted plant, and test with the universal indicator, that is pH indicator. Okay, so take some soil and make it in a solution in a glass, and take small amount of soil solution and add few drops of pH indicator. You can find the acidity or basicity or neutral of a pH solution. I mean, that's soil solution with the help of pH solution. Okay, here puts 2 grams of soil and add 5 ml of water and filter it, remove the contents of soils or sand, and test with the universal indicator paper. Universal indicator, that is nothing but the pH. So if the pH value is less than, I mean, which is red in color, that indicates the soil is acidic in nature. If it shows a blue color, it is alkaline in nature. Alkaline means basicity of the soil is more. So always the soil should be neutral. If it is acidic, you have to add base. If it is basic, you have to add acid. Okay, so here also always remember, the plants grow in a neutral state, mostly in the neutral state or basic in nature. So always we use fertilizers to decrease the acidity of the solution, acidity of the soil. So soil, in soil, so lot of humus, that is wastage from the animals, trees, leftover, I mean the leaves from the trees will mix into the soil, and also the dead bodies like animals, everything mixes into the soil. That releases the bacteria will decompose the humus, which releases the acidity. So when the acidity of the soil is more, we will add a base, that is which is nothing but the, remember, calcium oxide. This question is being asked from the last 5 years. That is why we add calcium oxide or lime to the soil, because lime or calcium oxide will decrease the acidity of the soil, which makes the soil neutral. Okay, remember. Okay, next, pH in human digestive system. So we already know that in digestive system there is an acid, that is HCl acid is being released to digest the food. So when we take or when we intake more food, it releases more acid for the digestion, but too much acid causes pain and irritation. That is nothing but the acidity. Okay, so to decrease the acidity, to relieve from the acidity, we use the bases called antacids. Why we use bases? Because acid can be neutralized with the help of bases. That's why they are called as anti-acids. They are antacids. Okay, so opposite of acids are bases, which can neutralize the acids in the stomach. So the common mild base which is used to decrease the acidity is milk of magnesia, which is a magnesium hydroxide. The magnesium hydroxide formula is MgOH taken twice. Milk of magnesia, which is a mild base used for the sake of acidity. So decrease the acidity. Okay, yes. So we also use to drink ENO, which contains magnesium hydroxide as a major ingredient. So there are lot of bases which can be used to decrease the acidity. Okay, so can you give some examples so that decreases the acidity in our stomach? Yes, it's a baking soda. Baking soda will decreases the acidity in our stomach, so we can use the baking soda to decrease the acidity in our stomach also. Okay, So hope you understand about the pH in our everyday life. Next is pH change as use of tooth decay. So pH change as the cause of tooth decay. So when you eat food, not only food, chocolate, so they will stuck in the gaps of the teeth. So when food stuck in our teeth, bacteria attracted to the food, and they start decomposing the food. So when bacteria decomposes the food, it releases the acid. It releases the acid which will decay the enamel of the tooth. So here the enamel of the tooth is made up of calcium hydroxyapatite. Calcium hydroxyapatite. So calcium hydroxyapatite is an enamel which degrades when it reacts with the acid. So always the pH of the mouth should be more than 5.5 but not less than 5.5. That is why we use toothpaste which is a base to decrease the acidity of the mouth. Okay, so acidity of the mouth can be decreased with the bases to prevent from the tooth decay. So tooth decay is caused when the bacteria decomposes the food stuck in our teeth. The decomposition process releases the acid which will degrade or decay the tooth. The tooth is made up of calcium hydroxyapatite. Okay, so hope you understand this. Tooth decay because of acids released from the bacteria, they are called as decomposers. Okay, so we always use base to decrease the acidity of the mouth. So it should be always more than 5.5, not less than 5.5. Next, self defense. So in day to day life there are some insects like honeybee or ants which will defend themselves by with the help of some chemicals. So ant bite or wasp bite, honeybee bite contains some acids or bases which will causes a pain or irritation. Okay, so they are called as the self defense with the help of chemical warfare. Okay, so not on see, chemicals are used to make the weapons like atomic bombs or atomic bombs, nuclear weapons. So here also there are some insects which they use the chemicals like acids or bases for the defensive mechanism. So here bee sting contains the acid which cause a pain and irritation, and also stinging hair of nettle leaves. There is a plant called nettle. It contains a tiny the leaves of the nettle plant contains a small tiny spokes or thorns which contains a methanoic acid which causes the pain or irritation. So that can be decreased with the help of acid can be neutralized with the help of what? Help of, yes, base. So in day to day life we use different types of bases like toothpaste. We can apply toothpaste on the nettle leafed exposed area or else baking soda which neutralizes the acidity. For the bee sting which contains acid, we can use the base like baking soda or toothpaste to to relieve from the pain and irritation. Okay, so this is what the self defensive mechanism with the help of chemical warfare in the plants and animals. Okay, next. So some naturally occurring acids and acids. So in day to day life we consume different types of food, so that contains acids. Like we should know that acids from last, not only from last 2 to 3 years, from last 10 years they are asking which type of acid is present in the vinegar or orange or tomato or ant sting. So here are some examples for the acids which are the natural sources. Okay, so vinegar contains acetic acid, and orange contains citric acid, tamarind tartaric acid, tomato oxalic acid, sour milk contains lactic acid, lemon contains same citric acid, and sting Remember, and sting contains methanoic acid which can be cured with the help of base, applying base. Nettle sting contains methanoic acid which can be cured with the help of base. Okay. So these are some acids. Please note down this acid because these are asked as a MCQs in our board exams. Okay. So hope you understand the natural source of the acids. Next, NCERT questions, in-text questions. So first question is, you have two solution, that is A and B. A and B. The pH of the solution A is 6. So if the pH of the solution is 6, is what? pH of the solution, if it is 6, it is considered as what? Yes, it is a weak acid. So 6 means weak acid. Next, the pH of the solution is 8. B solution is 8. So it should be 8 means it should be a weak base. It should be a weak base. And which solution has more hydrogen ion concentration? So hydrogen ion concentration means it should be acidic. So the solution with pH 6 contains hydrogen ion concentration more, that is why it is acid. Here the hydrogen ion concentration is less, that is why it is weak base. So here the A solution contains the concentration of hydrogen more. Which of this is acidic and which is base? So A is acidic, B is base. Okay. Next, what effect does the concentration of the H plus ion have on the nature of solution? So when the H plus concentration increases, that is nothing but, let me know in the comment section. Yes, that is acidic in nature. So when the hydrogen H plus ion concentration is more in the solution, that is acid. When the H plus concentration decreases, that will be base. Okay. Yes. Next. So do basic solution also have H plus ions? If yes, then why these are basic? So do basic solutions also have hydrogens? Yes, they will have the hydrogen, but let us assume NaOH. NaOH contains OH. O and hydrogen are in equal proportion. So here the hydrogen H plus concentration is dominated, suppressed, whereas dominated by the OH minus. So in the bases there will be a hydrogen, but in the form of OH minus, but not in the form of H plus. So when the H plus concentration is less, OH concentration is more, then it would be base. When the OH concentration is less, H plus concentration is more, then it would be an acidic solution. Okay. Yes. Under what soil condition do you think a farmer would treat the soil of his field with the quicklime? So we already discussed in the soil test for the soil. So that when the soil pH is acidic in nature, we use calcium oxide, which is a base. This calcium oxide is a base to neutralize the acidity in the soil. Next, slake lime or calcium hydroxide or slake lime, which is calcium hydroxide. We can use same calcium hydroxide. Calcium hydroxide or calcium oxide, both are bases. They can neutralize the acidity of the soil. Or chalk, which is calcium carbonate. So calcium carbonate Ca, CO3 can be used. Calcium hydroxide Ca, OH taken twice, or CaO, which can neutralize the pH of neutralize the acidity of the soil. Okay. So farmer always uses this type of bases to decrease the pH. If it is a acidic, so it should be neutral. Okay. So we use bases to neutralize the acid. Okay. Yes. Next. So more about salts. So we only know that NaCl is the only salt which we use for the taste. Like in the NaCl is the salt which can be edible, which can be used in our cooking. So but more about salts, chemical from the common salt. First is chloralkali method. This method is called chloralkali method. So in your NCERT textbook, Under the more about salts, there is an experiment, there is an activity which is chloralkali method. So in this we will understand what products can be prepared, produced from the NaCl. Okay, see here. So here this is the setup for the electrolysis. So electrolysis, this is the anode positive, this is a negative cathode. So anode, this is anode, already they are represented in the image, anode, this is cathode. Okay. So when you mix NaCl in the water, that decomposes into Na plus and Cl minus. Okay, Na plus and Cl minus. And whereas H2O will decompose into H plus and OH minus. H plus and OH minus. So here this plus ions are cations. Cations will move towards the cathode. Anions will move towards the anode. Okay. But what happens? Hydrogen will be collected. Hydrogen ion plus H plus will go towards the cathode. Here cathode. Whereas Cl minus goes towards the anode. So there are many H plus, not only one H plus, there are many H plus. So H plus will make bond with the H plus, which converts into hydrogen gas H2. So hydrogen gas can be collected at the cathode. Cathode, why? Because cations moves towards the cathode. So at cathode you can collect the hydrogen gas, whereas Cl minus will make bonds with the Cl, gives Cl2. Cl2 gas can be collected at the anode, which is a positive terminal. So, and the remaining Na plus and OH minus will be in the solution itself. So, unless and until the hydrogen and the chlorine gases are completely released out of the given solution, it gives Na and OH. Na and OH will make bond and they become NaOH. NaOH is nothing but the strong base, which is a caustic soda, sodium hydroxide. So sodium hydroxide can be produced from this experiment, which is called chloralkali method. Why it is called chloralkali method? Because chlorine is produced in this method, which is from the anode, and alkaline means, so alkaline nature means basic in nature. So it also produces the NaOH, which is a base, strong base. So that is why it is called as chloralkali method. It is very, very, very important in the case-based question. So they are asking mostly this type of topics in the case-based questions only. So please focus on this chloralkali method. So let me repeat once again. Chloralkali method will produce the chlorine gas and hydrogen gas and NaOH, which is a caustic soda. So chlorine gas is collected at the anode, and whereas hydrogen gas is collected at the cathode, and the remaining NaOH is collected at the bottom of the vessel, which is a NaOH sodium hydroxide, which is a strong base. Okay. So hope you understand the chloralkali process. So with the help of chloralkali process, we will produce hydrogen gas, chlorine gas, and also sodium hydroxide, which is a strong base. Okay. So first product, which is NaOH, can be prepared from the common salt. Okay. NaOH is mixed in the water, which is poured in the electrolysis method. So in this method, hydrogen gas, chlorine gas, and NaOH are the products. Okay. So next, more about salt. Chemicals from the common salt. First is bleaching powder. Okay. So we can prepare some of the chemicals with the common salt. First is bleaching powder. So how can we prepare the bleaching powder with the help of common salt? So here bleaching powder is produced by the action of chlorine on the dry slacked lime. So dry slacked lime means this is a dry slacked lime, calcium hydroxide. When calcium hydroxide reacts with the chlorine gas, which is produced in the chloralkali method, or else you can use the direct chlorine. So chlorine, when it reacts with the calcium hydroxide, which is a slaked lime, it produces CaOCl2. CaOCl2 taken twice. That is, and also H2O. Okay. This is the formula of the bleaching powder. So bleaching powder can be produced with the help of calcium hydroxide and chlorine gas. So how the NaCl is involved in this technique? So NaCl is used to produce the Cl2 gas. That Cl2 gas is transferred to the calcium hydroxide, which gives calcium oxochloride or else bleaching powder. So this bleaching powder, what are the uses of this bleaching powder? Okay, so bleaching powder is used in the cotton and linen and textile industries. So to make the threads of fabrics very clean and white in color, we use bleaching powder. So and also to make the drinking water germs free. So how this bleaching powder will help to remove the germs from the drinking, the water, contaminated water. Here, bleaching powder is a strong oxidizing agent. It's a strong oxidizing agent. When strong oxidizing agent reacts with the bacteria, so the membrane of the bacteria, which is the skin of the bacteria, when it is exposed to the oxidizing agent like where there are many oxidizing like KMnO4, potassium permanganate, or bleaching powder CaOCl2. So when they react with the membrane of the bacteria, they will rupture the bacteria membrane. So which leads to the death of the bacteria. So this is how the bleaching powder makes the drinking water germs free. Okay, so it will kill the germs and bacteria with the by their oxidizing property. Okay, so hope you understand the uses of the bleaching powder and the making of the manufacturing of the bleaching powder with the NaCl and calcium hydroxide and chlorine gas. So next is chemical from the common salt, same baking powder. Okay, so in day-to-day life we use baking powder for the in the kitchen for making pakoda, making pakoda or any kind of crispy things. Okay, so here baking soda can be made or manufactured with the help of the chemical name of the sodium, that is baking soda is sodium hydrogen carbonate. So how this sodium hydrogen carbonate can be manufactured with the help of sodium chloride, which is a common salt. So sodium chloride when it reacts with the water and carbon dioxide is transferred into this NaCl plus water solution with the ammonia. Okay, ammonia contains a pungent smell. So when these which chemicals are mixed together, that gives NH4Cl, which is a ammonium chloride and also a NaHCO3. So NaCO3 is a sodium bicarbonate, sodium hydrogen carbonate, which is a baking soda. From baking, so this is the mixture. From this ammonium chloride is separated, then NaHCO3, which is a baking soda, sodium hydrogen carbonate, is used as a baking soda. But here what happens, baking soda, when baking soda again heated, NaHCO3, 2 moles of NaHCO3, when it is heated in the presence of, when it is heated, it gives Na2CO3 plus H2O water. Okay, water is being released out of the NaCO3 when it is heated. So this Na2CO3 is used to produce the washing soda in the next slides. Okay, so what are the uses of this soda, which is baking soda? So baking soda is nothing but sodium hydrogen carbonate. Remember, baking soda is sodium hydrogen carbonate. It is also a ingredient in the antacids. So antacids means which neutralizes the acidity in our stomach. Okay, so sodium hydrogen carbonate, which is the antacid and also is a soda acid extinguisher. Why it is soda acid extinguisher? So in the chemical properties of acids and bases, we discussed a reaction called metal hydrogen carbonate reacting with the acid. So metal hydrogen carbonate is sodium bicarbonate, sodium hydrogen carbonate. When it reacts with the HCl, it gives NaCl salt plus carbon dioxide plus H2O water. So this carbon dioxide, which is used to extinguish the fire, so that is why we can produce the carbon dioxide with the help of soda, which is a baking soda, and acid. So that it is called soda acid. So soda acid fire extinguisher means Baking soda, when it reacts with the acid, it produces the carbon dioxide. Carbon dioxide is used to extinguish the fire. So it is called soda acid extinguisher. Okay. Next, washing soda. Preparation of manufacturing of washing soda with the help of sodium bicarbonate or NaCl. So in the previous slide, this NaHCO3, 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 when it is heated, it gives Na2CO3, Na2CO3. But here, that Na2CO3, when it reacts with the water, 10 aqua molecules, it gives Na2CO3 with 10 H2O. Na2CO3 with 10 H2O is nothing but the washing soda. So washing soda, sodium carbonate, this is sodium carbonate, can be obtained by heating baking soda. So when baking soda heated, when baking soda heated, it gives Na2CO3. It gives NaCO3 on heating, gives Na2CO3. Na2CO3, recrystallization of sodium carbonate. Sodium carbonate is Na2CO3 when it is reacted with 10 aqua molecule. Recrystallization means reaction of water with the crystal. It gives washing soda. Okay. Sorry. Next, washing soda uses. So how the washing soda is used? So glass and soap and paper manufacturing. So washing soda, sodium carbonate with 10 aqua molecules is used in the glass, soap and paper industries, and also removing permanent hardness of water. So what is permanent hardness of water? So there are some heavy metals in the water which can be contaminated, which leads to effect, which will cause disease to our body. That is why the permanent hardness, the hard metals, heavy metals can be removed with the help of washing soda. So washing soda is used to remove the hardness of water. So hardness of water is nothing but heavy metals contained in the water can be removed with the help of washing soda. Okay. Yes. So next, heating of the copper sulfate. Why this heating of copper sulfate is necessary? So why we are heating the copper sulfate? What is the motto of this experiment is to find whether the water molecule is present in the given crystalline form of the chemical. So this is the topic more about salt, water in the crystallization. So what is water in the crystallization? With the help of activity 2.15, 2.15, we will understand how the water molecule is present in the given compound. So what is water in crystallization? So here copper sulfate CuSO4 contains some aqua molecules. Let us assume 5 penta aqua molecules. When it is in blue color, so which on heating will loses its water 5 aqua molecules, which gives this copper sulfate will be white in color. Why the color of the copper sulfate is changing? Because the aqua molecules from the copper sulfate is being evaporated. Why not copper sulfate? Because we know water boiling point is very low. That is why from the copper sulfate with the 5 aqueous molecules is being evaporated. So this is the example for the water in crystallization. So there are many chemicals which contains water molecule in them. So they are called as water in crystallization. So water in crystallization means in the crystalline form there are some water molecules. Like in previous case also we have discussed Na2CO3 with 10 aqua molecules, which is called washing soda. Okay. Next, copper sulfate CuSO4 with the 5 penta aqua molecules. So there are many chemicals which contains water in them. So they are called as water in crystallization. So chemical itself, it contains water. So this is the activity to understand whether the water molecules is present in the chemical. So how they can be removed. Okay. So this experiment is to understand what? Water in crystallization. Okay. Hope you understand the water in crystallization. So next is chemicals from the common salt, same. So last topic of this unit is chemicals from the common salt, which is a plaster of Paris. Okay, so but plaster of Paris is not prepared from the common salt. Just remember, this is not prepared from the common salt. This is not prepared from the common salt. Plaster of Paris is a compound which is called calcium sulfate hemihydride, which is this plaster of Paris on heating the gypsum. Okay, what is gypsum? Gypsum is same calcium sulfate with two aqua molecules, which on heating will loses its aqua molecule, will convert into calcium sulfate with hemi means half aqua molecules. So this will be gypsum, which is found in the Paris as a ore. So that ore on heating will convert into calcium sulfate with hemi aqua molecule, hemihydrate molecule. Hemihydrate means half H2O, which is nothing but POP, plaster of Paris. POP is plaster of Paris. So which can be produced with the help of calcium sulfate with two aqua molecules, which is also called as gypsum. So this gypsum at 373 Kelvin will be converted as calcium sulfate with hemihydrate is called as plaster of Paris. This is how the plaster of Paris is prepared, and plaster of Paris is used to make the toys. So plaster of Paris is used to make the toys during the Ganesh Chaturthi. So Ganesh idols are made up of plaster of Paris, POP, and in the for ceiling, for plastering the ceiling, and for the walls also we use POP. Okay, so this is what the topics we have covered in the acids, bases, and salts. Okay, the last topic is plaster of Paris. So we finished that. Hope you understand this POP, manufacturing of POP, and the uses of POP. So next is the in-text questions, last in-text questions. So what are they? So first question is solution turns red. Okay, a solution turns red litmus blue. Red litmus to blue means that should be base. Its pH is likely to be. pH should be always for the bases, the pH value should be 8 to 14. Yes, 8 to 14. So this is acidic. This is also acidic. This is also acidic. So the last is this will be basic. So which turns the pH red litmus to blue, which is a basic. Next, a solution reacts with the crushed eggshells. Okay, to give a gas that turns the lime water milky. The solution contains. Simple. See, when the eggshells contain the calcium carbonate, so you don't need to remember that. But we know that the gas which turns the lime water milky is nothing but the carbon dioxide. So carbon dioxide is produced from the reaction. The solution contains what? So the solution react with the eggshells. Means when does the carbon dioxide releases? When acid reacts with the carbonate, metal carbonate, it releases the carbon dioxide. So the solution will be acidic, which is nothing but HCl. NaCl is salt. This is also salt. This is also salt. So HCl is the acid. When it reacts with the crushed eggshells, releases the carbon dioxide, which turn the milk water. Which turns the eggshells into milky white. Which releases the carbon dioxide. Carbon dioxide turns the lime water into milky white. Okay. Next, 10 ml of solution of NaOH is found to be completely neutralizing the 8 ml. That means, so 10 ml, 8 ml for NaOH, 10 ml of NaOH, 8 ml of HCl is required. 8 ml of HCl is required. We take 20 ml of same solution of NaOH. The amount of HCl required for the same solution, it should be double. Like 10 ml, for 10 ml NaOH will be for 10 ml NaOH we need 8 ml HCl. For 20 ml, if the NaOH is double, then the HCl should be doubled, which is 16 ml. So here 16 ml, 16 ml. Next, the which one of the following types of medicine is used for the treating ingestion? Ingestion means indigestion. So sorry, not ingestion, indigestion. So not having a acidity problem or not proper digestion. So we use mostly antacids for the indigestion. So here antacids will be the correct answer. Okay, next. Write word equation and then balance the equation for the reaction taking place. So we already know that how to balance the reaction. So I'll just write the word form of the equation into equation, but you need to balance it. Balance the equation and post it in the comment section. This will be the assessment for you. Okay. First is dilute sulfuric acid reacting with the zinc granules. So dilute sulfuric acid means H2SO4 reacting with zinc granules gives what? So when metal reacts with acid, gives metal salt, that is zinc sulfate, ZnSO4 with hydrogen gas. So this is the equation. You need to balance. Okay, note it down and balance the equation. Post it in the comment section. Okay. Next, dilute hydrochloric acid reacting with the magnesium ribbon. So dilute hydrochloric acid. When HCl react with magnesium ribbon, Mg gives MgCl2 magnesium chloride with the hydrogen gas. This is also a gas. Balance this equation and also post it in the comment section. Next, dilute sulfuric acid reacts with the aluminum powder. So dilute sulfuric acid, H2SO4 react with aluminum powder, Al, aluminum. Okay, so aluminum when it reacts with the H2SO4, it replaces the H2. Okay, it gives aluminum sulfate. Aluminum sulfate formula Al2SO4 taken thrice plus hydrogen gas. Sorry. So when aluminum reacts with the H2SO4, it gives aluminum sulfate with hydrogen gas. Next is dilutes hydrochloric acid reacting with the iron filling. So dilute hydrochloric acid. Dilute hydrochloric acid when it reacts with HCl, when it reacts with iron, it gives FeCl2 or FeCl3. So FeCl2, iron chloride with hydrogen gas. So these are the equations of the word form of the given equations. You just need to balance the equation, post it in the comment section. Hope everybody will balance the equation and post it in the comments. So at least I should see 10 to 20 comments of a balanced equation. Okay? Yes. Note down this equations. Okay? Take screenshot at least. Next, compounds such as alcohols and glucose also contain hydrogen but are not categorized as acid. Describe activity to prove it. So there is an activity for the electrical conductivity. We can conduct the electrical conductivity of acids and bases with alcohols and glucose. So whether acids and bases can conduct the electricity, whereas glucose and alcohols does not conduct the electricity, because acids or bases in the water solution, aqueous state, will produce H plus or OH minus, okay, which can conduct the electricity, whereas alcohols or glucose also contain hydrogens, but in the aqueous solution they won't release the hydrogen ions or OH minus ions, they won't conduct the electricity. Okay, so for this you can give an example of activity which is the electrical conductivity of acids and bases. Okay, next, why does distilled water not conduct electricity? Why does distilled water not conduct the electricity? Because distilled water does not contains ions. Distilled water is also called as deionized water. So they won't contain ions like metals. They won't contain metals like Na plus, sodium, or magnesium, Mg plus. So that is why they won't conduct the electricity. Distilled water won't conduct the electricity because they are called as deionized water. Next, whereas rainwater contains ions, heavy metals. That is why they can conduct the electricity. Okay. Next, why do acids not show acidic behavior in the absence of water? In the absence of water, acid does not produce H plus ions, which are responsible for the conductivity of electricity. So that is why in the aqueous state only acids or bases will decompose into plus H or plus ions and minus ions. They can conduct the electricity, whereas in dry form, not in the aqueous form, they won't conduct the electricity because of the absence of ions. Okay, yes, hope you understand about these questions. Next, showed pH values as 4, 1, 11, 7. 4, which is a weak acid, and 1, what will be the 1? Let me know in the comment section. Yes, it is strong acid, little strong acid. Strong acid. Next, 11. What is 11? Yes, it's a strong acid. Not completely strong, sorry, strong base. Let me correct, please. Strong base, 7. And whereas 7 is a neutral solution, and 9, last 9 is a weak base. 9 is a weak base. Okay, 9 is a weak base. So here, which solution is, okay, respectively, which solution is neutral, strong? See, first neutral will be 7. Neutral is 7. Strongly alkaline. Alkaline means basic. So which will be the strongly alkaline? Strongly alkaline will be base. Strong base, which is 11. Strongly acidic. Strong acid is 1. Weakly acidic is 9, which it is weak acid, and also weak acid is 4. Okay, weak acid is 4, and weakly alkaline. Weakly alkaline is which is nearer to the 7 value. Which is nearer to the 7 value is weak base is 9. Okay, so 9 will be the weakly acidic. Okay, so arrange the pH in the increasing order of the hydrogen concentration. Hydrogen concentration means acidity to basicity. So increasing in the hydrogen concentration means basicity to acidity. Basicity to acidity means in basicity, in basic solution, the hydrogen concentration will be very low. So when you are going from the base to the acid, the hydrogen concentration increases. So hydrogen concentration increases means first we have to start with the strong base, which is 11, which contains less number of hydrogens, that is why it is less. And after that, 9, as the value decreases, the hydrogen concentration increases. Next, 11 to 9, 9 to 7, 9 to 7, 7 to 4, 4 to 1. So 1 is the strong acid which contains more number of hydrogens. The hydrogen concentration will be more. So this is what the increasing order of the hydrogen ion concentration. Okay. Next, equal lengths of the magnesium ribbon are taken in the test tube A and B. Hydrochloric acid is added to the test tube A and acetic acid is added to the test tube B. Okay. So here, test tube A contains magnesium ribbon, Mg plus HCl. Mg plus HCl gives MgCl2 plus hydrogen gas. Okay. Whereas test tube B contains same metal with the acetic acid. So same metal with the acetic acid will be Mg plus CH3COOH gives, Mg replaces hydrogen, gives CH3COO 2 times of acetate with magnesium, because magnesium is +2, acetate is -1. So acetate 2 times of acetates reacts with the Mg, gives plus hydrogen gas, H2, hydrogen gas. Okay, so this is what happens in the test tube B. Here test tube A, test tube B and test tube A. So is added to the test tube B. Amount and concentration taken for both acids are same. Okay, so both the acids are same. In which test tube will be the fizzing occurs more vigorously, and why? Fizzing, see, fizzing means releasing. Fizzing means releasing of gas. So hydrogen gas releases more if the concentration of the acid is more. Okay, so in both this acid CH3COH and HCl, the HCl is strong acid which releases the more hydrogens because it contains more number of hydrogen. So fizzing will be more in test tube A compared to test tube B, because test tube B contains an acid which is weak acid which contains less number of hydrogen. The fizzing will be less, whereas fizzing will be more. Fizzing means release of hydrogen gas. Okay, yes. Next, fresh milk has a pH of 6. 6 means weak acid. It's a very weak acid. And how do you think the pH will change as it turns into curd? So as it turns into curd, when the lactobacillus in the milk, the lactose is a carbohydrate. Lactose converts into lactic acid when it is when the milk is converting into curd. So the taste of the curd will be sour. So that means the acidity is increasing. Acidity increasing means as the 6 value decreases to or 5 or 4 or 3 or 2. Not 2 because it's a strong acid. So it may be a 3, 4, 5. It's a acidic in nature. So explain your answer. A milk man adds a very small amount of baking soda for fresh milk. Why he is adding baking soda for the fresh milk? Because to prevent the milk to convert the curd or to neutralize the milk. Baking soda, because when you add baking soda to the milk, so it makes the solution neutral. It makes the milk neutral. So why does the shift the pH of the fresh milk from 6 to slightly alkaline? So when you add base, the 6 value shifts towards the alkaline because the basicity increases. Why does the milk take a long time to set as curd? Because we are not adding anything. The lactobacillus in the milk should action on the lactose carbohydrates. Lactose carbohydrate will convert into lactic acid. So it takes long time to convert the lactose carbohydrate to the lactic acid. Lactic acid will be acidic in nature. Okay, it's a natural procedure. Okay, so hope you understand the acidity of the curd and the milk. Okay, plaster of Paris should be stored in the moist proof because plaster of Paris is a CaSO4, calcium sulfate with half hemihydrate. So when it reacts with the atmospheric water vapor, it converts into gypsum solid, which is a strong solid with 2 aqua molecules. So when the POP is kept in the open air, it reacts with the water molecule, it converts into strong solid which is a calcium sulfate with 2 aqueous molecules. Okay, next, that is why it is stored in moist proof container. Next, what is neutralization reaction? To give 2 examples. Neutralization reaction means acid reaction with the base. Neutralization reaction in day-to-day life, to cure the acidity we use antacids to decrease the acidity and pain, irritation in the stomach. That will be the neutralization. And when bee sting or ant contains acid, when you apply base to it, it neutralizes. Okay, brushing also neutralization reaction. So in our mouth, the food stuck in our teeth will be decomposed by the bacteria that releases the acid which decay the tooth enamel. So to prevent that, we use base for the brushing teeth. Okay, next, 2 important uses of the baking soda, washing soda and the baking soda. Yes, washing soda is used to remove the hardness of the water, and also it is also used in the washing textile industry. Okay, next, baking soda is used in the food industry, bakery, and also in the kitchen. Okay, yes. So summary of this topic, okay, will be we completed the chemical properties of acids and bases with the activities and questions. Okay, next, common characteristics of acids and bases is electric conductivity, dilution of acids and bases. Okay, with the examples and activities, and pH and its everyday life. So we have already observed the pH scale with the values 0 to 14 and in day-to-day life, there are many acids and bases which can be identified with pH solution and pH paper. Okay, so pH values 0 to 6 will be acidic, 7 is neutral, 8 to 14 will be basic, and the uses of the pH range in our daily life. Okay, next, more about salts. So what is more about salts? So salts, with the help of salts, we produced some other compounds, chemical compounds, that is chloralkali method, bleaching powder, washing soda, and also baking soda. Okay, they are very, very important. With all these topics are covered with the help of activities and also NCERT questions. So this is what the acids, bases and salts. Hope you understand everything about the acids and bases and salts. So if there are any questions and queries, let me know in the comment section. I will try to write it in the comment section again. Okay, hope you understand everything from the acids and bases. Thank you so much for your attention. Okay, this is Vinith signing off. Bye bye.